My talk is about when multi-factor authentication isn't enough, dissecting a sophisticated phishing campaign targeting university infrastructure. But first of all, who am I? So my name is Marleen. I'm a PhD candidate in cybersecurity, and I'm at the SEC Lab, which is a research group led by Thomas Schreck at the Munich University of Applied Sciences. So what do I focus on in my research? So at the beginning, I try to train models first for cyber threat intelligence. Cyber threat intelligence is basically collecting, analyzing, and applying information that you have about cyber attacks. But then I took a deeper look into our data and figured out that we should first collect, analyze, and interpret the data and take care of data quality. Yeah, so this is what I'm working on first. But this is not the topic of my talk today, because I thought, okay, which attack should I present to you? Usually I work with data sets that have written information about attacks that happened somewhere. And I thought, okay, which one would be interesting for you? And then our university got hacked, and I was like, okay, well, let's take that one. That was on the 6th of June, so not long ago. And today I will tell you what the attackers did, how they captured our multi-factor authentication, and also our defense strategy to give you information that you can apply in your enterprise networks to make your company more secure. Okay, first some background to understand what I will later talk about and reference to. So MITRE ATT&CK is a framework that is heavily used to understand how cyber attacks work. And basically, it gives you granular and a practical framework to understand cyber threats or cyber attacks. And basically, if you really break it down, you can split an attack into 3 main phases. The first one is initial foothold. It's basically how attackers get into the network. And when they're in the network, they want to do something there. And basically, they do network propagation, which is how they get through the network. This can be, for example, when they're on one server through, for example, a phishing campaign, and they want to move to another server. This is called lateral movement, and this would be something that they do here. Okay, and then they finally reached the service, the web service they're interested in, and then they want to do something. They want to do an action on their objectives. And this you can call as out of the network, like how do they get the data out of the network? Okay, so this is quite simple, in, through, and out, okay? And what MITRE ATT&CK does, it gives you concepts. And one concept is tactics, and tactics is what are the attackers trying to achieve? It's the why, like what is their goal? And the techniques define how attackers achieve their goal. It's how they get to that goal. And MITRE ATT&CK gives you an abstract way to describe those single attack technique steps. And why is it cool? Okay, first, it's built from actual adversary behaviors observed in the wild. So it's nothing that was developed by research somewhere in a lab discussing how we should define this framework. It's something that people who work with attacks day by day develop based on their observations, based on the attacks that they see. And the second point is it addresses the full spectrum of IT infrastructure. There are different domains, and today I will talk about the enterprise domain. Okay, so what about the tactics? We have again here in the network, through the network, and out the network. And here you can see the different tactics. It's not important that you can read the single tactics, just imagine there are different tactics that you can have, for example, initial access. And they look ordered, but they're not. So if you analyze attacks, you will see that there can be jumps backs, like loops. So an attack doesn't have to be, and is often not, a straight line of steps that occur in a certain order. There can be loops back to reconnaissance. For example, someone got initial access to a network, tried to get some persistence, achieved that, and then he has to go back to reconnaissance to see what's there in the network, what else is there that I could use. Okay, keep that in mind. This will be important later. Now the techniques, sorry. Okay, as you can see here, I shortened the table. It is very long, so it wouldn't fit in there. Just imagine there are some tactics that have many, many techniques that can be used to achieve the goal here in the header row. So in the header row, you have the tactics that you've seen before, initial access, for example. And every tactic can be achieved by certain techniques. And those are the ones here below. And there's even more. These techniques can have sub-techniques. Why is this so huge? You can see here, it's version number 17.1. This framework is so great when you use it in operations that they kept on developing it. There's a new release every half year. That's pretty cool, quite useful. Okay, let's look at one technique. What is that? So for example, phishing. You all know phishing, like the phishing emails. Phishing emails belongs to tactic initial access because it is often used to get the initial access to the network. And what does a framework do? Don't try to read it. I'll explain just to give you a brief overview. You always have a definition, and the definition gives you an abstract description of what the attack does. So you can see, okay, they send phishing messages to gain access, blah, blah, blah. They may send emails, but also victims may also receive phishing messages that instruct them to call a phone number where they are directed to visit a malicious URL. And interesting, so it doesn't always have to be an email. And this way, they try to describe in an abstract way what an attack does. And also, now it becomes really interesting. You also have mitigations, like what can I do against this technique? This is shortened, there's a longer list, but one example that you all know is user training. Okay, users can be trained to identify social engineering techniques and phishing emails. Cool, so this is something that you can do to mitigate phishing. They also give you examples how you can detect it. For example, through application logs. And you also have platforms listed where these techniques can occur. So not every technique can be used on every platform. So you could also filter based on certain platforms that you use. Okay, so this is a technique. And now I talked about these mappings, right? And you can do cool stuff, so you don't have to read it. It's just what kind of cool stuff you can do with this framework. Is here someone who loves knowledge graphs? Knowledge graph lovers here? Yeah, perfect, okay. You can use these mappings to build knowledge graphs and to filter based on them. This one links the data sources. The data sources are the ones linked to the detection, and then link it to the techniques that can be used so that you know where to look at if you want to detect a technique. Easier said, you say, okay, what techniques can we use for collection and how can I detect them? So you just look at the data sources that you should look at, because it can be really, really, really hard to find the small pieces, the indicators to trace down an attacker. Okay, enough about the framework. Let's go to the attack. We had this email on a Friday afternoon, the 6th of June. It was a Friday afternoon around 2 p.m. Imagine people being in meetings, quite task saturated. They got this email, and it looked quite good. So here you see an alias something, Hochschule München, which is our university. And it's called release messages something, and it was sent to my professor, who was the first one who reported it. And yeah, so, and you had email content here saying that you have 12 messages that you can get, and there was a button to click on. Okay, so this looked quite good, and some people clicked on it. And if you look a bit further, there's a display name. I don't know how much you know about emails, but it's pretty unsecure, basically. You can, there is a email header where you can set a from field, and this from field has an email and a display name. It's just a string that you set. That's all. So they set Hochschule München as display name, and it was sent from ogus@bu.edu. This is Boston University. So this is a university that we trust. right? The problem is, so we assume that the attackers might have access to this account, or they did something that's called email spoofing, where you spoof someone else's identity just by putting the name there. Anyhow, this email reached multiple employees, I think over 900 or 1,200. I have it on the slide at the end. Okay, so many people got this email, and it looked quite good, so they clicked on the button. Yeah. But if you look a little bit longer on it, then you see that there's a time mismatch between when the email was received and when the email content was created. Okay, I think Boston is 6 hours before us, and then you still have some hours left. So I assume that they created this email content, and then it took 2 or 3 more hours till they sent out this email, and it reached us in our time zone perfectly on Friday afternoon. Might be planned. Okay. The second thing that's interesting is the link behind the button. So if you hover over a button, then you can see the link behind it. And I took that link and looked at it and was like, okay, well, that looks quite good, right? You have something with hm.edu. Is it a domain from us? No, it isn't. And this is a really nice trick that they used. So first of all, you have the prefix, which determines the protocol. So HTTPS, okay. And there's hm.edu, which is our domain that we usually use. But here, it is a prefix. It is very unusual that you use a prefix with an @ in an URL, because it's not common, but it's technically possible. So they tried it to mimic our email address, our domain. But this is just something, you can write anything there. Doesn't matter. The important thing is here highlighted in pink. Let's start from the last part. This is the top-level domain, .link. Email protection is the domain, and there's a subdomain URL. So this is the domain from the attackers. This is just a prefix that they used. That has nothing to do, technically, with our infrastructure. And then there was an identifier hash value at the end. Okay, so even as someone who's trained, this email was pretty good. What happened then? Okay. The first part was initial access. We had the phishing email. Now, what happened was credential access. So they got our credentials somehow. And they achieved it through the technique Multi-Factor Authentication interception. Sounds crazy? It's crazy. So what did they do? They sent the email. Employees clicked on it. And then you landed on a Microsoft 365 login page. And that login page was really well made. So it looked like our original Microsoft 365 login page that we use. And they built the full 3-step authentication process. So you were asked to enter your email. Okay, done. Then your password. Okay, done. And then your TOTP, your one-time password. What is a one-time password? So a TOTP is a time-based one-time password. You know this from logging into maybe your bank account or so. You have a second app on your phone, and this app gives you a time-limited code that you have to enter here in your Microsoft account in this case. And this TOTP token is usually valid for 60 seconds, so a very short period. So what they did was, this login page was fake, right? It was hosted by the attackers. And then you entered your email, your password, and your one-time password. And then the attackers forwarded it to the real Microsoft 365 page and logged in with these 3 values that you just entered here. And this must have been completely, fully automated, because the token is just valid for 60 seconds. After the user entered it, it might have been like maybe 30 seconds left, 20 seconds left. And during that time, they logged in through the real Microsoft 365 account. Okay, so now we have credential access, interesting. What was next? This is how they gained persistence. Through account manipulation. It was just one more step. So after logging into the page, the Microsoft 365 email account, all they did was they added their own credentials automatically. And this was all done in seconds. Okay, so now the attackers had their own credentials in our accounts. This is called persistence. They can log in whenever they want. They don't need to send any more phishing emails or so. Okay, well, cool, like, isn't it hard to build that? Okay, there's a tool on GitHub. It's a free open source repository called Evil Engine X. Check it out. It's, yeah, press a button. It has a really good README, so you get a full documentation how to use it. And basically, it is a reverse proxy for sending phishing emails that automates this. And if you open that GitHub repository, then this is the owner. He also has an Evil Engine X Mastery training course available online. Yeah, I didn't try that out, but I think you will know how to use the tool afterwards. And I found a little disclaimer at the end of the documentation saying that it should be only used for penetration testing. Okay? I don't know why you should need a reverse proxy to send out phishing emails. I mean, if a company hires me to do that, I would ask for an additional user account to send them. But anyway, so if you're interested, there are tools out there and attackers have access to them as well. Okay, let's do a little recap. This large table here, what happened? We had phishing in the first step, the email. Then they had initial access. They had something in our network, which was an email in our email accounts. Then they gained credential access through this multi-factor authentication interception by getting this TOTP token through this wrong or fake login page. And then the third step was account manipulation. They manipulated the accounts to add their own credentials. And now you see, we already have a loop, right? From here to there, back to here. So it's not linear. It's also very interesting to analyze, to see what happened. It's not trivial. What did we do to defend it? So the most important thing here was a cybersecurity playbook, it's called. A playbook is simply just a written document that defines and coordinates the steps that you do in a certain case. In this case, the playbook was called phishing. And the first step was send info email to employees. So after the phishing email was reported, the security team directly sent an email to the employees saying, hey, careful, there's a phishing email, blah, 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 and so on. But this is a formal process that we do. This email was opened by 1% to 2% of the people, and it doesn't stop them from clicking on buttons. So the next steps are technical. So you kind of try to block the fake website. And there are different ways to do it. I don't want to get in too much detail at the moment because these steps highly depend on the infrastructure that you have. And it also can be quite hard. You can't block the website on all devices at the same time. For example, Sentinel-1 just runs on our managed devices. Those are Windows laptops. I have a MacBook, so I'm not covered. Okay. And the last step was answering emails from employees. And this is, and it will always be, the most important step in this whole defense, because we only heard from this attack because employees reached out to us. And it's very, very, very important to thank them, to support those who were affected, and to not let this email go out and then no one responds, because this is the most important thing, that your employees are aware and know who to talk to if something like this happens. And this is also the most time-consuming task. This kept them busy for hours, but it's very, very, very important. And this way, there was no damage due to the awareness of the employees, and the attack got well mitigated. I will talk about this while referring back to that picture. So you remember this whole process of how they gained persistence, right? And this was not part of the playbook, but one of our colleagues said, okay, could we do maybe a fake user and see what happens based on this fake user? So, okay, the attackers use fake websites, so we use fake users. Okay, sounds good. This was a spontaneous idea, so this was nothing that was part of the playbook. Because the problem was, at the end, there's not a problem, but only 2 employees really entered their TOTP token. And somehow nothing happened in their account. We assume that the TOTP ran out of its lifetime before the whole process was done, before they logged in. So we didn't have any employee who had credentials added to their account. So how did we find that out? We created a fake user. This fake user then got the email. We clicked on the button. And then we entered the TOTP token. And then we saw how they added automatically a whole bunch of credentials to that fake user account. So this was like, imagine like a honeypot user that we used to analyze the attack. And that was a pretty cool and quite creative idea to monitor the attack. And now, this way it got visible that they are capable of adding their own credentials. Okay, so basically this is what happened at our university in the infrastructure. But what if we didn't stop it? Like, what could happen beyond that? And there are many different ways. So once an attacker has persistence in the network, there are many ways that you can imagine what could happen. I have just one idea, one attack here that I want to present to you because it's a quite easy steps that you can do from after you have this persistence in the network. You can do cloud service discovery. So in our case, for example, OneDrive is connected to our Microsoft 365. You can log in to OneDrive, and then you can do discoveries through this email account. And next, you can do lateral movement by exploiting these remote services, so getting on the OneDrive services. And then the next step would be collecting or collection. So you can get data from cloud storage. But this is just collection. So what's the next step? Of course, exfiltration. You have to get the data out of the web service in this case. And this would be exfiltration over web service. So what you do as an attacker is you use infrastructure that is already there. So if there's a OneDrive connected, cool, you go into that. And if there's a web service that allows you to download this data, you of course use that. And the good thing here is that web services usually talk to each other using TLS. So it's encrypted communication, which is good protection for attackers as well. Okay, so how do we break the kill chain? Kill chain is a term that comes from the military because those were the ones who first kind of tried to document these kind of attack steps. And basically what we did was the phishing emails were sent. We couldn't do anything against that, right? So the first way to break this chain is to have user awareness so that they don't land here in the multi-factor authentication interception. And then, even if that happens, if we know what's going on, we can stop the attackers from manipulating the account. And then this whole thing can't happen because it's really hard to stop the attack once it's here because it's really hard to find the evidence what happens there. Okay, so I talked about data mappings. Let's have a different perspective on this attack. Here are the 7 techniques that I just explained on the previous pages. So you have phishing, multi-factor authentication, deception, and so on, account manipulation. And then you can take the mitigations on the right and the detections and data sources that are linked to the techniques to trace down this attack. And the interesting thing is that these combinations, especially also the techniques in how they are combined, are very specific for certain APT groups, so attacker groups. And then you can, for example, try to find out which attacker group attacked you based on the techniques that they use. Because these are humans as well, so they have knowledge in certain programming languages, or they are more front-end or back-end people. You know, they can't know everything. So it gets really interesting when you start looking at the data this way, like what are they capable of? What are they interested in? And which attacker could that be? Yeah. And this way you can build knowledge graphs, which is cool. This is what I'm trying to do. Yeah, so here I talked about this previously. So network traffic can be a data source to trace down, for example, phishing, but also exfiltration. Problem is, or it's a good thing, due to privacy reasons, the traffic in enterprise networks is often encrypted. So we as security team also don't want and can't break it. So we can't look at this most of the time. So basically file, like here in this case, a phishing email, is a very important data source. And now we come to user training as a mitigation. So awareness training is one of the most important things that you can do against phishing. And phishing is often the first step into the network. And you can also see here that cloud service discovery has no mitigation. Why is that? Yeah, simply what should you do? If you have this email account, you see what services are linked. There's nothing you can do against it. So there are steps, there are techniques that you can mitigate at that step. Okay, what are our lessons learned? Next time, you'll take security awareness training seriously. Awareness is key when it comes to figuring out or getting notified that an attack is happening. So I have a little statistic here for you. How many employees clicked on the phishing link? So the previous attack, the last one that we had, 9 people out of 900 who got the email clicked on it. That's 1%. This is already really, really low. So usually you have like 7 or 8% after awareness trainings. So this were already really low. And this attack, the one I talked about, 2 people clicked on the link and went through the whole authentication process out of 1,216, which is very, very low amount of people who clicked on it. And the latest attack, which was 1 week later, no one clicked on it. Woo, yay. Maybe they didn't read their emails, but could also be a reason. And now the second lessons learned that we have. So one day, you will have MFA enabled. Make sure you enabled it and not someone else. So we are already enforced it at our university, but with the one-time passwords. And we are currently rolling out using passkeys because you haven't understood security if you still use passwords. This is why. So do you know passkeys? These little things? Okay. So basically, these passkeys, they hold a private key. And this private key is only on this device, and the website where you log in with this private key gets a public key. And your browser application binds this key to a website domain, which is called the relying party. And then it's impossible to use the same passkey on a fake website with a different URL. So this passkey wouldn't have worked on the fake login page from the attacker because the domain got checked. This is something that we trust the user to do, but it doesn't work in practice. We don't have the time to dissect every link behind every button. So passkeys is something that this attack wouldn't have been possible with passkeys. So this is my conclusion for this talk. Use passkeys. It's cool. Thank you so much.